I've tried refreshing several times.
Yeah, okay. All right. There it is. It's running. Interesting. A little weirdness there. I think it was running, but it's caught in latency or something. Well, hello, everybody. Good to see you. And I want to welcome you to SkyTour Livestream again on the 12th of June. It's June, Daryl. Wow.
It sure is.
We are closing in on the summertime nebulae, dark sky nebulae, Milky Way. Oh my gosh. And I think this is going to be the first season where the telescope is in optimum condition. Because it wasn't quite there. But now it is.
You know, we're just a little over a week from summer in the Northern Hemisphere.
Right.
And actually, earliest sunrise is tomorrow morning.
Really?
Yep.
Wow. That's really cool.
Yep. And then latest sunrise is about a week after the solstice.
Yep. I want to take time to say hello to the folks that are here. I want to say, of course, special shout out to Vera Lucia Campos, who was the first one in the chat. Welcome. Daisy and Zoe Amethyst, David Schmidt. We have also with us, we have Donald Kunzer, and we have some new faces. I see this guy Daryl again. Renee Cruz is here with us. Hello, Renee. And we also have Ricardo, who has joined us. Donald Kunzer actually had some music to share with us. It was actually an interesting quote from a record album that he had mentioned. It was from the Allman Brothers, and the lyrics were, the sun is a massive incandescent gas, a gigantic nuclear furnace, where hydrogen is built into helium at a temperature of millions of degrees. I actually didn't know that was in the song. That's really cool, Donald. Thank you for offering that up. That's kind of cool. Michael Klagus is with us. How you doing, Michael? What's happening? Michael was out on a lake today. And it's like, well, pardon me. Beautiful lake, beautiful day, probably. It's been great. We sit over the lake here where we are, and it's a smaller lake, but it really is beautiful here. You know. And we have John G with us tonight. Hi, John. Welcome. I think that John is one of our latest subscribers, so welcome to SkyTour Livestream. I hope you will enjoy what you see here. And Ricardo, I believe you are as well. So hopefully we'll be able to hear from you guys a little later as to what you thought. And Daisy and Zoe, is Lane with you tonight? Let me know. JSCO, hi there. How you doing? I believe that's James, right? James, I think that's you. I checked out that video you sent me, and it looks like an aircraft, but I don't see the flashing lights, and that's what bothers me. So I think that's pretty interesting, you know. Ronnie Audette is here. Hi, Ronnie. How are you? Good to see you. PG. Hello, PG. That's Petita. She is in Pennsylvania. Good to see you. And we're going to go cruising tonight and have some fun. So let's check it out. All right. So as you can see right over my head here, it's actually not quite dark in the building yet. But for those that are new to this and want just a refresher, this is our telescope control segment over here. And I can just say, like, this controls the telescope. This is the north, south, east, and west over here. Okay, and we have these other buttons. These are how we get into the computer of the telescope. The computer's right here. Okay, there's a telescope in the building right there. This is our main view. Ta-da! And it's going to be filled with wonderful things tonight, hopefully. Then over on this side over here, this is our camera control section. Now, this guy right here, exposure time, that's one of the most important fields right there. All right, we're going to be changing that exposure time, and we're also going to be changing the gain. The gain is the sensitivity of our sensor on our camera, and that's really important. All right, down here we have our autofocus system, so we're going to be messing with that a little bit because our camera can and our system can autofocus now. It's a nice feature that's working really good, really well for us. I'll just increase our exposure a little bit and get us up to let's say, yeah, that's pretty good. I'm just going to raise it up pretty high there. This is you might wonder what that is. That's the star Spica. And what I mean by Spica, the way we know it's Spica is because we have a planetarium that is linked to our telescope. And you can see right here, it says STLS with a crosshair. That's the location of the telescope. And there's Spica, the star that is just there in the field. And if I bring up our crosshairs here in the field, okay, you can see that Spica is just below center. So I can bring the telescope down just a little bit and get Spica just about in the middle. Let me just actually reduce the speed a little bit here. All right, and I'll just go up a tiny bit. All right, and then I come back here and see where our crosshair is. You can see where it is relative to the star. And if I just want to align everything, I just hit a special key, which I just did, and now the crosshair is as close as I can get to Spica with this reasonable setup. So we're good. And then when we come back, all right, this of course moves all over the place. It's meant to, wherever you are, it'll go. But this gives us a series of crosshairs that we can use to position things. Pretty cool. So that's neat. So Daryl, what's going on out there? You said it was pretty warm out there today? Daryl, are you muted?
Yeah, sorry. Yeah, it's been pretty warm here, about 10 degrees cooler than you are in Arizona. Been up in like the mid-90s last couple of days. Supposed to be tomorrow also.
Okay.
Been clouding up some too.
Yeah. Well, that's pretty warm out there, huh?
Well, with the altitude, yeah. I mean,
Yeah.
the only thing keeping us from being as hot as you are is the altitude.
Yeah. Yeah, I mean, I'm actually not that hot because I'm in Connecticut, okay, and the other side of the continent compared to where the telescope is. I'm running the telescope out in Arizona in the desert. So we're actually just having some fun out there. And I want to say hi to Alice. Alice is here. How you doing? She goes, how much for your telescope? Asking for a friend. That's kind of funny. So Judy McClelland is here. Hello. How are you? It's good to see you. John G says, OBS is off. Explain that. I'm not sure what you mean by that. And look, it's Tara Diulis, the artist in Arizona that actually made our door for SkyTour Livestream. She is amazing. It's good to see you, Tara. Tara was just at I think you were at the Field Investigator Appreciation Dinner tonight for the Mutual UFO Network investigators in the Phoenix area, correct? And she'll tell us. So we're just waiting for it to get a little darker. As you can see, we still have some sky here. If you can see, if I come into our planetarium program, I actually have the atmosphere turned off. If I turn it on right now, then the atmosphere will show up. And when we come out of here, if we zoom out, I'm glad you had fun, Tara. Okay, if we zoom out now, and let's see if I, okay, that's without, and that's with the atmosphere. And now, if we move over a little bit toward the western horizon, you'll see that our western horizon is just getting a little bit darker. It looks good now, but you can see this brightness up here. Part of that's from the moonlight, you know. So we have a moon out there tonight, but we're still going to try to figure out what's going on. Hi, Bonnie. Bonnie is Adahada77. She's here. Yeah. So we're up here by Spica, and if we zoom in, you'll notice that in that Spica region, we're in the constellation of Virgo, and Virgo, of course, is the Virgin. This is Virgo. She's holding wheat in her hands, and Virgo is one of the constellations, along with Leo and Coma Berenices, that have tons and tons and tons of galaxies in them. And Daryl, I think you know how many galaxies are between those three constellations, roughly, right? I think we talked about that.
No, I don't know. There's a ton of them.
Yeah, I think you said one time, I think there were hundreds of galaxies just in this one region of the sky.
Well, I've said the realm of galaxies, basically springtime, if you go from Ursa Major down through Canis Venatici and Coma Berenices and Leo and Virgo, of the 1,000 brightest galaxies in the sky, 3/4 of them are in that area.
Yeah,
from Ursa Major down to Virgo.
Just incredible. Well, I think I want to take a look at some of these. I don't know which one I'm going to go to first. We can try the Sombrero because it's kind of bright. That might be kind of neat, huh?
Sure.
All right, so we're going to go to the Sombrero galaxy, and you'll see the stars streak. And we still have to focus the telescope and do all of that yet. And it may not be dark enough to do what we're doing, but we're going to try it anyway. Okay. Oh yeah, we got some stuff going on here. This is good. And I'm going to go to a 1 second exposure because that is a standard exposure that we use. And we're heading to Algorab. This star right there, you see, that tells you where we're centering. And Algorab is actually a star that we will use as a waypoint star. And from there, we're going to go to the galaxy if it's dark enough. It may not be dark enough yet, but we'll see. Okay, I'm assuming that's Algorab, and it's going to pull it somewhere toward the center here, I think. If it does. I mean, again, like I said, it may not be dark enough. I might be jumping the gun here, but we'll see. And we're going to bring our gain, our sensitivity up. Yeah, I still see sun on the horizon there, so we're not quite ready. I just want to just jump the gun and get going, don't I? I'm just crazy. I just want to do this.
Tara asked me a question after you asked me about the galactic neighborhood, and while we're waiting, may I essay a bit more precise answer? Tara, the universe, you've ever seen pictures? There's like filaments and voids that all the matter and the galaxies and the clusters and superclusters tend to run in filaments with empty space around them. It looks like a great big cosmic spider web, and our whole part of the universe, I believe, Marc, correct me if I'm wrong, is called the Laniakea supercluster.
Yeah, Laniakea, yep.
And the Virgo cluster is just a part of that, and I've said before how we and all the galaxies around us are falling toward the Virgo cluster, and then the Virgo cluster itself is heading toward what's called the Great Attractor, which is farther south down in constellation Norma and Triangulum Australis, the Southern Triangle, and all that is all part of the Laniakea supercluster.
Yeah, the thing about Laniakea is if you see images of it or representations of it, and the lines between them are just the logical connection lines. It has to do with everything from motions to matter streams and things like that. Laniakea looks to me, interestingly, like a neural network. It really kind of looks like a neural network, which is really kind of interesting. I wouldn't, I'm not suggesting the universe is alive, but it's definitely looks very, very much like a neural network. So I think that's kind of a cool observation.
I know exactly what you're saying. I tend to agree with you. Makes a guy wonder, or a girl wonder.
It does. Makes people wonder indeed. Yeah. Okay. It's not dark enough to do focusing, so we're still waiting here. As I suspected, I was trying to rush it to find the Sombrero galaxy, and I couldn't find it because it's just not dark enough yet. But not to worry. I'm going to I will drive us north a little bit, and I will drive us east. Okay, and then we will find it. Then we can focus. Izabela, hey, how are you? That's Izabela Melamed from Sofia, Bulgaria. She is one of our mainstays in Skyter Livestream. She takes care of all the tables of contents for us for every stream. I can't believe it, but she does it every time, and she's amazing. So, and she's a really good artist. All right, there's the Sombrero there, and let me see how many stars I have for focusing. That may be enough. Let's find out. I'm rushing everything tonight. I just want to get going and try it out, you know. All right, so now we're gonna scan in and see if it can focus here. Tara says, "Do we know if there are more gravity detected near the Great Attractor?" If there is more gravity detected near the Great Attractor, I mean, the more mass you have, the more gravitational strength you have in that local region. If that's what you mean.
Thinking that might be a better way to put it. It's the largest concentration of mass in our part of the universe, the Great Attractor. But then again, that's all part of the larger Laniakea supercluster.
Yeah. But as Daryl was saying, and as we were saying earlier, the amount of gravity is dependent on the amount of mass in the local region. And for instance, our sun has the highest amount of gravity in our solar system, but the sun is by far one of the smaller stars. There are some stars that are so big that if you put them where the sun is, they'd go well past Jupiter in size. And that is amazing, considering it takes us years to get to Jupiter with probes. You know? So that's pretty crazy. It might be too late for me to do my autofocus as well. But we'll try it. Yeah, it says I couldn't find it. So we're just gonna have to wait a little longer. Darn it all. Alright.
Well, if you be patient, it'll start getting dark earlier in a couple of weeks.
I know, I'm trying to be patient, let me tell you. Okay. Alright, let's reset this. And get ready to start again when we have a few more stars. Then we can actually start to then we can actually start to look at stuff in earnest. Okay. Hey there, Neutrino, how are you? He says, Neutrino says, our little dwarf star is a giant to us. You betcha. It sure is. You're absolutely right. Our little dwarf. And we are. Our star is a dwarf. It's actually a yellow dwarf. That just means that it's on what's called the main sequence, which is the normal hydrogen fusing line that you see. Stars that are actually making hydrogen into helium in their cores. That's the normal operation for stars. And for our star to be doing that means it's doing a normal operation, so it's sort of in the main region of other stars, the main sequence of stars that do this. And that's where the main sequence comes from. So it's pretty cool. Let me just come in a little more here. And by the way, it's also windy out in the desert right now, so I don't know how steady the views will be tonight, but, you know, we'll give it a shot. I'm going to increase the gain. Okay, that's 300. And let's see.
No stars. Too few stars.
Yeah, but that's because it's slightly out of focus. I took him a little bit out of focus. See how many more I get when I bring it more toward focus. So that's alright. If it gets darker, that helps us anyway. We could actually enhance this a little bit. See, in the East Coast here, it's 11:23 in the evening right now. So we start pretty late at this time of the year. But it'll be getting darker sooner, and we'll be able to go back to just taking care of this the right way and not dealing with so many issues of light and dark. And we'll probably start earlier in the evening, which is great. Okay.
Poor Izabela, her espresso machine broke. No coffee for her.
Sorry to hear that, Izabela. But I guess that's what happens when you use it so much, because you stay up so much. You know?
I have about 3 or 4 different backups for coffee, Izabela. If all else failed, I have my old cowboy coffee pot. I can make some cowboy coffee.
Cowboy coffee pot?
Yeah, you know, just like you see in old westerns.
Oh, the little standalone cow with the little thing on top of the. I mean,
Yeah,
I don't drink coffee.
It's percolator, I guess, but
Okay.
you know, it's blue steel with the white spots all over it, and used to stick it in the campfire and make cowboy coffee.
Okay, I guess that's what you do.
And I have a French press, and I have my primary coffee maker, and I have a standby coffee maker, which doesn't work very well. That's why I don't use it. I could always just boil water and make coffee if I had to.
Yeah, that's true. Okay, well, we're just going to try and get our focus samples here and see. Ah, there we got a good focus. See that? We want a parabolic curve. See that little curve that you see right there? That shows that we do have a center focus. Now we can go to best focus, and now the telescope can focus. It goes all the way back across, goes out of focus, then comes back to that perfect focus. Boom. And now the telescope is focused well. Okay. And we'll do that again at some other point in the night as well. It's 34.38 Celsius in the building out there. We have that right here. Alright. But now we have our stars. So now let's go and see if we can get to the Sombrero. Actually, we can just drive up to the Sombrero now, because it's right here. It's right nearby. Alright, well, that's going a little too far. I had it in too high a gear. Let's bring it back down. There we go. Alright. And we'll move it on over. The Sombrero looks good, you know, even with a nearly full moon, to be honest. So we're going to check that out. Alright. Let's head west a little bit with the telescope. You can see some of the stars in the screen here as we are moving over. Alright. Moving on over. Here we go. Yeah, we should see it now. When I come into this field of view, we should see it. And that looks like it's right there. Can you see that, guys? I'll show you. Because we're going to take another picture of it. But what we do is we actually stack pictures. So we actually take image sandwich. We just keep stacking them on top of each other to make them look good. So there it is right there. So what I'm going to do first is I'm going to go to my auto guider setup. Sorry about that. And I'm going to set our guiding parameters. All right. And I'm going to set the left to right guiding pattern, setting to 15. And I'll explain what that is perhaps after. And then I'm going to go to our declination, which is our up and down, plus 90, minus 90. Right ascension is in hours with 24 hours because that's one day. It's like the longitude lines extended out into space from the Earth, but just in hours. Okay, so the deck rate is going to be 17. The up and down, that is the angle, plus 90, minus 90. So the up and down rate will be 17. And here we go. All right. So we're set there. And now I gotta come up and we're gonna go into our status for our guider. And in the status, I am going to get into the status. And you see these numbers? Sorry, I got allergies. This is the guiding status. It's guiding the left to right and up and down. And that's how much it's moving to keep whatever's in the center exactly centered. So now that we're guiding, we're going to take a 15-second photo of this field of view. And here we go. And what we're going to do is we're going to actually stack it. So the first one we're going to take, this is our stacking down here. You can see all of our stacking parameters. The first one, you see the progress bar over there on the right lower part here. First image comes in, we should see the galaxy here in just a minute. There it is. And it looks like we've got a little too high a gain here for the moon being out. The moon's actually pretty close to it, I think.
Yeah, let's see. The moon was in Libra last night, so
yeah,
it's over there just to the east a little ways.
Yep. Okay, that's a better view. And let's see if we can change the color. That's more like it. The first one's always a little grainy. These diagonal lines, these are an artifact that's on our sensor or on one of the lenses. And I'll be out there in less than a month, and I'm going to be fixing all that to get rid of those lines. Those will be gone, gone, gone. It's probably going to be something stupid, too, when we get to finally see what it is. And for those who may recall, we are running Starlink out here, so we now have a beautiful access to the night sky, and it's fast and beautiful. This noise is going to go away slowly but surely as we do this. Now let me see if I can. Let's move this down a little bit. Okay. So this is the Sombrero galaxy. It's an interesting galaxy because you can see this dark line across the front. That's actually what's called a dark lane. And we'll actually take a look at the moon too, when we can peek at it. Gonna blow out your eyes though, because it's gonna be pretty bright, but we'll make sure. Michael Klages says, "Did you hear about the meteor that hit the JWST mirror, the James Webb Space Telescope mirror?" Yes. I think it was mirror element C4.
C3.
C3, okay. And these impacts are not unexpected. So it didn't destroy the mirror, but it did mar the mirror. So what they have to do is they have to try and just work around it. When they process, they remove that section of the data. I say just like that's easy. It's not. It's a difficult process to do that. Okay.
I sent you a link this morning to Anton Petrov video on YouTube talking about that, and there I've seen various numbers floating around. He said that was actually the 5th impact they've noted on the web.
Yeah, it's had several. You're right. One of them actually punctured the heat shield. There's another one that hit the instrument package on the back.
Oh.
But again, it doesn't have the same. It doesn't have like rigorous shielding on it, you know. But keep in mind that this isn't just dust that's floating around at this Lagrange point, and it just sort of like touched it. This is stuff that's coming through at high speed. Just like in Earth orbit, you can get whacked by something that's in Earth orbit as well. You know, that's why there's such a concern for the astronauts when they're doing spacewalks. That's one of the biggest concerns, is that they might get, you know, killed by a piece of dust moving through at 20,000 kilometers per hour from a higher orbit to a lower orbit, or vice versa. So there's a lot of dangers out there. Okay, we've got 15 stacked. Keep in mind that when we take pictures while the moon is out, we always get a lot of noise. When we take pictures without the moon, it's much cleaner. But you know what? I wanna keep the telescope operational, make it work. Very cool. While we're doing this, we could go check out where else we want to go. I'm wondering, maybe we should head way up into the north.
That might be a good idea.
Yeah. We can go to Messier 3 and check it out. That's fun. Want to do Messier 3 as well?
Sure.
Alright, let me come down here. Keep in mind that, like I said, with the moon out, faint galaxies and the moon just don't get along. The fact that we can see them at all is testament to the instrumentation we're using. With the moon so close, it's really, really impressive to be able to actually see a galaxy that's so faint that it's still picked up with a lot of its detail. Okay, these dots are all noise that we can get rid of in the processing later, but we also don't see these when on a moon-free night. We can also put in a bilateral filter to kind of knock down some of the noise, like that, and we can also add an unsharp mask to sharpen up the detail, and then go back to our view here and process them a little different. That's pretty cool. That's neat. Izabela says, haha, my wishes come true. Messier 3. Really? You want to see Messier 3? Okay. Hey, it's the Desert Dweller. What's happening, brother? What's going on? Yeah. Okay, John G says, is most of this debris caused by humans? Actually, no. There's a lot of leftover debris in our solar system from the formation of the solar system. So a lot of that stuff sometimes ends up getting an orbit of its own around the sun, and sometimes gets dragged by some other gravitational force, such as the force of the planet Jupiter or Mars or the Earth itself, or the moon. and then it gets moved out of its original orbit and starts making, say, a new orbit around the sun or whatever. And so it can end up taking on a whole new orientation and carry with it a whole new set of speeds, velocities. Okay, a velocity is a direction and a magnitude of speed, you know. So if something's whipping around, it could actually go right through an astronaut or a spacecraft of any kind, a satellite like James Webb, if it's going fast enough.
Yeah,
Okay.
that Anton Petrov video I sent you, he was talking about Hubble. He said that they have noted the rate of impacts on the Hubble Space Telescope has gone up like by a factor of 700 over
Really?
what they saw like 10 years ago. And I would have to guess that is man-made stuff.
Well, the Hubble
know.
is in Earth orbit, and James
Yeah.
Webb is not. So, you know, when someone, if you ask a question about James Webb being hit by man-made stuff, the answer is very, very unlikely. It's highly likely that it's not, because
Right.
it's a million miles away, and if it's man-made, it's probably came from the James Webb itself, perhaps. I don't know, but honestly, when it's in Earth orbit, certainly there are things that, oh, there goes a Starlink satellite, most likely right there. Now you go, well, why is it a dash? Because we're taking a 1 second exposure over here. So you're seeing 1 second segments. So in 1 second, it goes about that far. That's what you saw. Hey there, DPFX. How are you? What's he saying here? Oh, you said, yeah, they said there was a terrestrial rock he found. Okay. Yeah, I actually, as a kid, I actually found some really, meteor wrong. I actually found, what I thought were meteors, and I brought them to a science guy, and he says, no, that's just slag from industrial processes. I do have a meteor behind me that's real meteor from an Argentinian fall. It weighs about 1,000 grams. It's solid iron. And so that's real. That is an actual, and it really passes all the tests, and chemically it's a meteor. It's clearly from outer space. And I kind of like something from outer space. You know, that's just sort of cool. Really is. All right, let's check out a good cluster. We're gonna head up to Measure 3 here, and here we go. So now watch. We're gonna right there. It's gonna say it's gonna do high precision slewing again, and we're gonna find a waypoint star up here in the vicinity of Measure 3, and from there it's going to leap on over to Measure 3, and we have another globular cluster up here too to check out. And then there's one beyond that we'll have fun with too. There goes 2 satellites. Probably one of them is a Starlink. Alright. Okay, we're centering on Muffred, which is a star nearby. And there's Muffred. And now we should be heading to the Globular Cluster, which is right there. Here it is. These are objects called halo objects. They actually go around the galaxy, kind of orbit the galaxy, sort of from the outside. You know, they're not in the galaxy much. They actually can come plunging through the galactic disk in some cases, but then they come out the other side, and when they come plunging in, they can attract stars to them or release stars from them. And so they're kind of like, I don't know, I kind of think of them as cosmic galactic lint. You know, they're always pulling stuff with them when they go. But they can hold tens of thousands of stars. This one certainly does. And they actually have some interesting stuff inside, meaning, okay, so here's a star. Let me just show you. So this is a live view of this Measure 3 globular cluster. And sometimes you can see patterns inside, patterns of the stars. And in one of the other clusters we're going to go to shortly, you'll see that. Daryl knows exactly what I'm talking about.
Excuse me?
You know exactly what I'm talking about.
No, I don't. I'm sorry, I was typing. Marianne just showed up.
Uh-oh, Marianne. Oh, no. Hi, Marianne. Marianne Robb, along with Tara, are members of the Sky Tour livestream family and are members of our organization we've made for the Sky Tour livestream group. And Marianne is our treasurer, and Tara is our secretary. And I'm something, I don't know, I guess I'm the guy that just talks a lot. But well, it's nice to see you, Marianne. And Marianne's with Stacy Wright, who is the director of the Phoenix, or the Arizona Mutual UFO Network. You know, Stacy runs that organization like it ought to be run. She does a really, really fine job. Really fine job. Yeah, so this cluster looks beautiful. Let's take some pictures here and see if we can get a few shots. Let's go. We'll do a 10-second photo, and we're going to stack this. All right. So we'll come out of this, and I'm already zoomed into 100% on our sensor right now. Okay, so let's see what we get. Okay. Color correct. There we go. Well, there you go. Look at that beautiful cluster. And as soon as the next frame is taken, you'll notice that a lot of that noise goes away. And when the next picture is taken, you're going to see again, this model noise is going to get even more subdued. See that? This is what stacking does. It removes that random noise, but allows the data that's there, the data that's always persistent, to come through and get higher and higher and higher in the stack, so to speak, of data. So this is beautiful Measure 3 globular cluster. To see its distance, the distance to this globular cluster is about 32,000 light years according to our planetarium program, but that program has been known to be wrong. But they are definitely far away because they're halo objects. And for the record, we're about 23,000 light years from the center of our galaxy, and this is over 30,000 light years away. You know, yeah. JSCO says image stack much faster now. JSCO has been watching over the last couple of years with us. Well, actually, I'm only doing a 10-second photo of this cluster because it doesn't need any more than that. But I could, if I wanted to, I could just come over here and show you a little bit more of the interior of the cluster by dragging this down. Then you can actually see more of the stars inside, see? So we can actually process on the fly and show you things that are going on inside there. This really is a pretty cluster, Daryl.
It is. A lot of big yellow stars in it.
Yeah. Which begs the question, you know, what are those stars and why are they all mostly yellow? No. The answer, which Daryl has mentioned a few times and I've said a few times, is that these are stars that are called population 2 stars. These are older stars, actually among the oldest in the galaxy and possibly the universe if they all formed around the same time. Yep. These stars are so old that in their atmospheres, they generally don't have any additional elements other than hydrogen and helium. Thank you, Vera. Thank you so much. That was very, very nice of you. Yeah, we are just so happy to have people with us tonight checking things out. You know, there's 43 of you out there watching us right now. Let's come on to the chat and say hi. It's really good to see you guys here. So these stars being population 2 means that they're very old. Now, when I say old, again, let's suppose for sake of argument, since the galaxy was formed. Okay, that's for sure. They could be plus or minus a few 100,000 years, a million years. But if you look at the stars, if you look at their atmospheres, the stars themselves, they don't have a lot of other elements in them, like in our periodic table, because it's in the hearts of stars where elements are forged. Okay? Carbon comes from hydrogen being converted to helium, and then helium being converted to carbon. Carbon going to nitrogen, to oxygen, to fluorine, briefly on down, all the way to, at the most, iron in the core for the most massive stars. But iron's only number 26 in the periodic table. We have 118 elements in the periodic table. So what does that mean? It means that other processes take over to form some of the further elements down in the table. Stars like our sun and other stars like our sun can make elements other than hydrogen other than helium, by using a process called a slow process, and it's a very slow process. If you're familiar with the process, it's also known as the neutron capture process, but don't worry about any of that. All I'm saying is stars like the sun can only ever make hydrogen into helium and not really go from helium into carbon very well. All right? If you're slightly more massive, you can make helium into carbon, because to go from hydrogen to helium requires 13 million Kelvin in temperature, and to go from helium to carbon requires 100 million Kelvin. So that means a more massive star with more heat in the middle to make that next transition. And that's what we got here. In these bigger stars, these globular cluster stars don't have that capability. They're making hydrogen into helium, and that's about it. Because that's about all they have for their size, Yeah, to get notifications, thanks, Daryl. That's a good point. You got to click the bell, but then drop the list down. There's a little drop down there, and just hit all notifications. Otherwise, you may not get a notification that the stream's happening. And it's like, I don't understand why YouTube does that. But I want to thank you guys for coming out to our channel and hanging out with us. It's a lot of fun, even on a full moon night or a nearly full moon night. Yeah. So, again, we have stacked 34 images in our image sandwich. So, as you can see, the data looks pretty good. If we actually push this a little, when you actually pull out some of the data, you can see that the noise is actually almost gone. And that's exactly what we're looking for. And the color correction, I can just do that real fast. And here's the color. That's the corrected color. And we'll just pull this down just a little bit. And that right there looks more like what we expect to see. Look at that beautiful thing. Now, just so you know, that's not the size on the that's the size at 100% of the sensor filling the screen, okay? Meaning, it's a small section to the center of the sensor. If we see the whole sensor and we do an auto fit, this is the size of the whole sensor. Okay. So the native size is 100%, and that is this one right here, if you notice. And it still looks pretty good, doesn't it? Yeah, JSCO says, wow, so pretty. It really is. It really is. And what's really interesting is that these clusters, it's very unlikely that they have planets in around the stars in these clusters, because there's not enough material to make planets here. So this is probably an area that's kind of devoid of life, right? Yet this star, that star, maybe one of these over here, which are all in the foreground of our view, and the cluster is way back here, okay, they might actually have planets around them. They might be stars that are like a K star, which is more sort of an orangey star, or a G stars or so, or maybe a F star, I mean, the stars, remember, go from hottest to coolest. It's OBA, FGKM. O's are the biggest, hottest stars in the universe, and those stars are just absolute powerhouses. Most of their energy is given off in the ultraviolet. That's how powerful they are. Okay, this is measure 3. So what I'm going to do, it's called M3, and I'm going to put GC for globular cluster next to it. And now what I'll do is I'm going to pause this, and then I'll save. And then you'll see, real briefly, you see that a FITS file was saved. That's good. And then we're going to save it just as you see it, like this. And that'll be a ping file. Alright, let's wait for that. And then I say save exactly as seen. And now you see the ping file. This is now going up to our amazing server up in the cloud, which is free access to all. You can go look back and see months and months and months, actually almost a full year, of photos that we've taken all the way from last summer to tonight. So enjoy it, and these are free for the taking, and I know that Izabela will share the link probably, and it's kind of cool. Okay, we're going to clear this now and go to our next object. And it's been saved, so we'll see it. Alright. Let's do this and go back to 1 second. There we go. Alright, so this is a 1 second exposure. You can see how the noise changes, but the stars don't. Okay, that noise is random, and that's noise on the sensor. So again, by stacking, that noise gets averaged out. We lose that, and all we see is the data sticking through. What else do we have here, Daryl? Let's see.
What does that one say? Snow globe cluster?
Yeah, that's this. Is that the? Well, that wasn't the. We are at M3. Yeah, we want to check that one out.
Sure.
Okay.
Well, with the moon bright, globulars might be a good target.
Yep. Okay, so now we're gonna go here. First things first. What's that?
Says it's the ghost globular.
Yeah, I don't know what the ghost globular is. I've never known it by that name. It's NGC 5466. NGC is a catalog name, guys, as is Mel 124. That stands for Melot. This is New General Catalog, NGC. So that's what we're looking at there. Are we going to Arcturus? That looks like Arcturus. It is. Arcturus is the brightest star in the constellation Boötes. And we're at 100%. So let's go back to auto so you can see what we're looking at here. Wow. Yeah, it's a bright night.
It is.
Yeah. Alright, so now we're going up to the snow globe cluster. There it is, I think.
Getting up in this part of the sky, M13 might be a logical choice.
I agree.
Yeah.
Yeah. Alright, well let's do a 10-second shot on this one as well. And then get rid of our hyper view here. That's sort of like a little hyper view I use to allow us to see what's going on the whole time. Alright, and now let's see what the 10-second shot shows. Doesn't look like much until we add a few bits of processing in there like this. And there is our snow globe cluster. And I have to color correct a little bit. There we go. That's pretty. It could stand to use a little bit longer exposure. So I'm going to clear this. And I will go to 15 seconds. There we go.
Globular clusters vary a lot. This one, I mean, on Stellarium it was marked as a globular. It's much sparser than M3 was.
Yeah.
And if we do M13 next, you'll see another great big change.
Yeah, actually that's kind of cool to do that, because it'll be neat to show folks how how the globulars look different And it all has to do, in a lot of ways, with how many stars they have, how far away they are, and their relative size in the sky to us as well, which relates in part to how far away they are.
What was the NGC number on this one?
I think it was 5466, wasn't it? 5466.
5466.
You got it. Yeah, let's see now. First of all, here in our planetarium program, it says the distance is is that 52? What is that? 32? Looks like a 52,000 light years, or 32. I can't tell. The writing's weird.
Yeah, it's 52.
Okay. Is that what it says online too?
Yes.
Okay. So 52,000 light years could explain why it doesn't look as filled in, because we might be seeing it through a lot of interstellar dust in our galaxy, and so the light is suffering what's called extinction. Okay, so we're at 63% here. You can see the stars as we zoom in. You know, this is pretty cool. There we're just at just over 100%. Look at that. Let's actually try to give ourselves just a little bit of a processing edge here. That's something. Now, if you were out there, what?
Oh, I think I can see why they called it the snow globe cluster.
Yeah.
It is rather sparse, but it is the globular.
Yeah. Grape Soda says, no extinction of dust in my house, buddy. Okay. Fair enough. I think that's pretty cool. And Tara says it's faintly mysterious. She's right. It is. That is funny. And Calabos is here. Hey, Calabos, how are you? Yes, Calabos, Starlink is running out there, and we have a much faster system now. Fantastic response times. And we're getting good promised data streams either way. And it's going to be, hopefully, working for us. The last time we streamed at night, we had absolutely no dropouts from Starlink. And I think most of the dropouts are during the day, because during the maintenance phase in the morning, I had one dropout for about 12 seconds. And when I looked at the position of the satellites, we're just waiting for one more satellite to come down to grab. And once we got it, we came back up like nothing. So that's pretty cool. This is neat. Let's take our dark curve and move it over a little more. That's what this is. This curve here you see, this is the RGB curve of the data, red, green, and blue. And this line represents the dark threshold. So if I bring it way over here, then you'll see it get pretty bright. Okay, but if it comes over and it starts to climb the peak, then it starts to clip off that bright sky background. And roughly at the peak of that, we should be at a perfectly dark image. Okay, and we sort of are. And then this one here is the mid-tones. Okay, the tones that are not bright white. Okay, so if we drag those to the right, you'll notice that we actually end up getting a much subtler reduction in the stars in the center of this, but it's not a bright cluster. If it was a bright cluster, it'd make a difference. Okay, but you can see that. But we can bring them over and have it climb the data, and you'll see that we get an amplification of the noise and everything else in there. So we tend to leave it kind of off, just off to one side like this. And then we constantly do color correction, all right, to help do that.
Izabela, that's a good question. I was waiting for a chance to answer. Plus, I think you asked a question a little while ago about why don't globular clusters flatten out, I think, or something like that. Uh, do globular clusters rotate? Uh, that's a good question, and some of this is supposition on my part, but I want to say they're rather like elliptical galaxies, that they don't rotate like a spiral does, or like planets around our sun, our solar system, that form a plane. I think the stars are all in separate orbits around the center of mass of the cluster, but the cluster itself does not rotate as a body. If that makes sense, Mark, would you care to
Yeah,
expound on that?
yeah, and everything Daryl said is correct. The only addition I'll make is, whereas it doesn't rotate as a whole, what we do notice is that the stars do have orbits, but you got to understand that every star is affected by every single other star in this cluster. And to figure out its orbit, the orbits could be quite complex. They're not just elliptical orbits or circular orbits around the center. Okay, they're orbits that are dragged and moved around by other stars. For all we know, the stars orbiting the center of mass in these clusters may be on orbits that are never the same twice. They might just always be migrating and precessing and moving around and changing. And all it takes is for one of the stars to get kicked out, or for the stars in the galactic disk that it will be orbiting to tug on it at just the right way, and it'll change things up all over again. So there's a lot going on here.
Yeah, you might consider it like a swarm of bees, or a cloud of gnats or something,
Yeah.
But they're all in constant motion. But something you said, was it Izabela? Let me look. Something the article mentioned on this globular cluster. Let me pull it up again here.
Okay.
The snow globe cluster. This globular cluster is unusual insofar as it contains a certain blue horizontal branch of stars, as well as being unusually metal poor like ordinary globular clusters. It is thought to be the source of a stellar stream discovered in 2006 called the 45-degree tidal stream. This star stream is approximately 1.4 degree wide star lane extending from Boötes to Ursa Major. So it's like it's leaving a stream of stars across the sky.
Yeah, remember what I mentioned about how these are halo objects, so as they orbit the galaxy, when they pass through the disk of the galaxy, that's going to perturb and change how things work inside those clusters. So they may pick up or leave behind stars. Well, that residual effect is going to be present in their continued orbit. So if it's leaving a stream of stars behind, that could explain why it's so sparse. Maybe it's been leaving the stars behind the entire time of its existence, and we just don't know that, right? So that's an interesting prospect. I really like this new music. I just love this. This is really good. Okay. We've done 36 of these, so we're going to pause this. I'm going to call this is NGC 5436, the snow globe. Or 5466, right? Yeah, 5466, sorry. Alright. Alright. That's going to be a GC, Globular Cluster. And this title is exactly what's going to show up on the server when you go to look. Okay. Alright, we're going to save the raw file, which you see right there, the FITS file. That's the astronomical format. But that format is one that you can get a free viewer for if you want to look at it. But We're also, I'm going to just do a little bit of an adjustment here. All right. Actually, I'll do a black level adjustment, sorry. Okay, so I'm going to take a black level set now, take that and move it over a little bit. Okay. And now we will save it exactly as seen. Alright, there we go. And you'll see the ping file. So there we go. So that's going up to the server. So far we have Mesher 3 up there, and we have NGC 5466, the snow globe. So we'll clear this. And I think the moon is going to be pretty close to Mesher 13, isn't it?
Oh, no.
No? You sure?
Hercules is just to the west of here, to the to the east of Arcturus.
Right.
And I mean, there's M13 right there at the upper left.
I see it, yeah.
Yeah. And the moon is going to be way down in Libra or
Yeah.
Scorpius.
Yeah. All right, well, we'll see.
M13 would make a really nice contrast to the one we just looked at.
Oh, I think so. It's going to be very, very different. So let's just get our... Let's bring my computer back up. There we go. And now we come back over here and let's say go, go, go. Go, go, go. And off we go. High precision slewing. And I got to change our time here to 1 second again. And go to our hyper mode. I call it a finder mode, basically. And let's come down here and put our whole sensor on the frame here. There you go.
James.
James Dugan? Is that James Dugan? Yes, it is. Hey, James. How are things in Australia? That's good to see you, James. And by the way, folks, just so you know, our field of view in this telescope is literally huge. We have 4 full moons across, 3 full moons tall. All right, that's how big this view is. And when we look at the moon, you'll see what I mean. Okay, there is Mesher 13. It's quite a beautiful and copiously populated star cluster.
Yeah,
So let's go to 75% of our sensor size on this right now and check it out. Look at that, huh?
You'll see
All right.
where 5466 we just looked at was so sparse. This one, by comparison, this is the best, biggest, brightest, most populous globular cluster in the northern sky.
Right, right. And if you notice, there's a dark little line here, a little line here, okay, and a little line here, and that has a fun little name of the propeller. It's in the globular cluster. Daryl loves looking for the propeller every time we go look at this.
Oh yeah.
All right, let's do a 10-second shot. You don't need a whole lot of time on Mesher 13 because it's so bright. So we're going to do that. Come out, and we're going to stack. And let me see if I have to clear the previous stack. I do not. Okay. As you can see, we're building up the image over here. And then it gets read off the sensor, and ba-boom. Hey, look at that. It's pretty great. And we'll get the color rendition's good. And as you can see, the center is almost blown out, so it's almost too bright. But watch now. Watch this noise that I told you about. Watch what happens. Ready? You see it go even further away. Okay. It did. You didn't see it too well, I'm sure. And as it goes, we're going to see more. I'm going to take us down a little bit. Look at that beautiful cluster. That is bright and beautiful.
when you see M13 here, it has, oh golly, I forget, hundreds of thousands of stars in it, I guess.
I don't know the count. There is a known count to the stars in this cluster,
Yeah.
and
I'd have to
it's an estimate. It's all an estimate.
Yeah.
Vera Lucia Campos says Southern Hemisphere rules. I don't know. I guess I'd have to agree with that. But you know what? You don't have a pole star. We do.
So there.
So there.
Yeah.
All
Well, what they say, Sigma Octans is the southern pole star.
The closest, yeah.
And I've noticed watching time-lapse videos that one of the the European Southern Observatory's VLT time-lapse video, that you can make out Sigma Octans in the southern sky pretty easily on the time-lapse if you watch the large and small Magellanic Clouds as they rotate around the South Pole. They form a kind of an equilateral triangle with Sigma Octans.
Yeah.
But Vera is right that you have the best globulars in the sky down there.
Omega Centauri.
Omega Centauri and 47 Tucanae. Omega Centauri has 4 million stars in it, and it's about as big as the moon in the sky. It's so big and bright you cannot miss it. That's the one I got to see one time when I was down in New Mexico back in the 94, 95.
Wow.
And
Grape soda, don't worry about the misspelling. That's fine. Yeah, go ahead,
amazing
Daryl.
to see.
Wow. This is great. Hey, Cosmic Ray, how you doing? Messiah. There you go. Messiah 13 here. And it's a gorgeous globular cluster. We'll give it its name there. Just remember, okay, Skyter Livestream, STLS, it's your one-stop shop for gorgeous. Okay, let's see here. We're gonna let this thing fill in some more. It's pretty. So this is what we got. Mizar 13, Globular Cluster. We're going to let that fill in. Actually, why don't we just go and just pull this out full screen for a minute so people can see it growing up there like that. That's really pretty. Again, this is live views of the universe, guys. It's all live. You know, we don't, you know, we don't play around. We just like taking live images, and we do it fast. And the reason I do it fast is because I want to give you something every few minutes. I want you to see a new object, because that, I think, is what is really exciting about astronomy. And tonight, so far, we're doing globular clusters because the moon is out. But when the moon gets high enough, we'll actually check out the moon as well. Hey, D. Smith, how you doing? I see Daryl said hi to you as well. It's great to see you guys. So good to see you, and we're having a lot of fun tonight. As the summer approaches, our sky just gets better and better and better. Right now, the springtime is galaxy season, but summer is approaching. And if we were to go long enough, we could actually start looking at some summertime objects, except with the moon out, the things we like to see in the summertime sky get washed out, even with the moon in the dark sky sight like this. But boy, it's something. Really looks pretty. We look at things called dark nebulae, as well as bright nebulae. Dark nebulae, to me, are the most interesting nebulae in the sky, and the reason is because that's where life originates. That's where life originated for our solar system. And yes, stars provide life, yes. And so, of course, when stars are formed, then they make light, and thus planets that are formed around them can then host life, possibly. But the components that make up the planets are in those dark nebulae. And the dark nebulae are the most important parts of the fundamental, foundational, life-making mechanisms in the universe. The dark nebulae are the ones that do this. And dark nebulae are little grains of dust, carbon molecules, carbon molecules, or silicates, okay, based on silicon. And they actually form giant molecules of these things. And then in the depths of space, sometimes other materials fall and are forged in these dark clouds, like formaldehyde, like carbon monoxide, like methanol, carbon dioxide ice, CO2 ice, water ice. And they freeze onto the dust grains and form a coating of a bunch of these building blocks of life. And then when a star is formed, well, then those are driven off, and now you have this slurry of material just waiting to form a planet and build a planet with all of this material that was made in the dark cloud. That's why dark clouds are so exciting, and that's why they're the most exciting nebula to me in the entire universe. And when we tuned this telescope, I wanted to make sure we could see a lot of those dark clouds. And Daryl will tell you, we see a lot of the dark nebulae out there, don't we, Daryl?
Oh, yeah. Well, that's something we started sort of specializing in last year, kind of by accident, at least to begin with. That we saw some neat dark objects, Barnard objects and such, and they made such nice images at the image scale of Marc's telescope that we started looking for them and found some really fantastic ones.
Yep. And you'll notice that when we start looking at them that many of these nebulae are long drawn out filaments. And if you look in our galaxy, you'll see that there's many such filaments. And what we're seeing some of these very filaments in our imagery. It's really beautiful, Okay, we've done 47 of these stacked. So let's let me push this out of the way so I can see my telescope again. Go ahead, move it. There we go. Okay. And so there we go. Everything's fine there. Okay, good. So now what I'll do is I'm going to pause this. I've got Measure 13 Globular Cluster put in up there, and we're going to come back here now. We're going to pause this. Let me pull out the name. We don't need a name in there right now. And then I'm going to pause this right here. That's a beautiful, beautiful cluster. And before I pause it, I want to do one more thing. Let's drag down this brightness just a little bit to reduce the brightness in the core. Oh, there we go. Okay, so now by reducing the brightness in the core, we resolve this to stars. And why did I resolve it to stars? So that you can see the propeller very clearly. There's that dark line right there. There's this dark line right here. And then this vertical dark line. So it goes down and down. Look at that. That three-bladed propeller it's not a real propeller, obviously. It's just a void in the stars. It just happens to be a coincidental pattern that's made by all the stars in the cluster. But it's really pretty and neat.
Could you try to increase the zoom a little bit? See how much it'll bear?
Yeah, I'm just going to save our image here as a FITS file, and then I'm going to save it exactly as seen. And you'll see our ping file. That one you can just double click on when you're looking at the server, and you'll see it. Okay, it'll look just like this. Let's zoom in now. We're going to the Globular Cluster Measure 13. So there it is. There's the propeller. And we're kind of at the limit with the telescope zoomed in like this because we are a wide field telescope. So we're actually over 220% on our sensor right now. Whereas at natural scale, 100% is our image scale. Okay, but we can go all the way to 800. Let's go there. Let's go. I'll show you what that looks like. Boom! Ha! Look at that. That's cool, huh? You can see the individual pixels in the sensor, and there's the propeller right there. Okay, kind of cool, huh? Neato. Even with a full moon, that ain't bad. A nearly full moon. All right.
Even inside the propeller, there are stars there.
I saw that, yeah.
Yeah.
Yeah. Okay, we save
Would you
this.
like to try 4565?
Yeah, we can do that. I did save this, correct?
Yes.
All right, so then I can clear this and take us over to a galaxy that, you know, could be fun to look at, as long as it shows up well. But I'm sure it will. Let's try it. The galaxy is known as the Needle Galaxy. NGC 4565, which is actually one of Daryl's favorites and mine, actually.
Well,
And there it is, right there. All right. And there it is. That's also known as Caldwell 38. These are all up here in this area here. These are all catalog names. Caldwell 38, New General Catalog NGC 4565, Index Catalog 3543. This is a Galactic Cluster catalog, and this is another Galactic Cluster catalog. But we're going to go here and check it out. And it
I
should
see.
be...
Stellarium calls it Bernice's hair clip.
Yeah, okay. Yeah.
It's funny.
I think they make these names up.
Oh yeah.
I swear. Okay, get this back. And now let's go off to our Needle Galaxy. This is a pretty cool galaxy when you see it. It should look pretty good. It's darker now. You know, when we looked at the Sombrero Galaxy up to the very beginning, it just wasn't dark enough. I couldn't even get the focus system to work properly because it was still too light. But it's okay. I think we're going to this star here, and I'm not sure. Oh, it's Vindimiatrix right there. Going to Vindimiatrix. You see it right there. So it centers it up, and then the Needle Galaxy is going to show up right where that star is. So wherever this goes, all right, and wait 1 second, and whenever that stops centering, wherever it stops centering, there it goes. Okay, so I'm gonna leave the cursor right there, and let's see how close the galaxy shows up in the middle. Okay, there we go. That's so far so good. Now it's centering it up. That's pretty close. Look at that. It's right there. Not bad. That's the Needle Galaxy. But what does the Needle Galaxy look like? Oh, well, let's just zoom in and check it out. Once we do let's do 20 seconds on this one. Okay. And we're going to get rid of our hybrid view, go over to our live stack. Let's see here. All right, go over to our live stack and clear this. There we go. And you can see that we're building our image over here. The way this works is light is falling on the sensor. The sensor is very sensitive. Right now we're going at 200 gain. We're actually 150 less than we normally go because of the moon. And there it is. There's the needle. That is so pretty. We're going to zoom in on this. Right. We'll go to 75% right now. Look at that. Look at that, huh? What a pretty galaxy that is. And let's first do a color balance. Let's get rid of some of that green Here we go. And let's now do a sharpening up. There we go. That kind of shows you what this looks like. It's almost edge on. It's kind of like this. It's not edge on like this, all right, like that. It's sort of like that. So we're seeing a bit of the bulge on the bottom and a little bit of the bulge on the top. And then you see that dark lane that galaxies that are spiral galaxies will typically have when you see them edge on like this. That's all that dark interstellar dust that I told you contained the building blocks of life, and that from which we were made and other many stars were made. So that is the most important element, I think, of a galaxy, is the amount of dust and interstellar dust that it has. Right? That's just my feeling, and as an astronomer, those of you who know that that's what I chose to go to school for. I knew I was going to be an astronomer at age 9, same old story. But I felt that these nebulae were a very key and very important aspect to life in the universe. And as you can see, life in the universe is born from these galaxies, obviously, because we're made of the star stuff that was made in the stars in the galaxy.
I always thought this was reminiscent of the Sombrero, except it's tilted a little bit more than the needle is.
Yeah.
As you said, we're seeing it almost edge on.
You're not, not quite edge on, right? But still, it's really cool. It's very, very beautiful. I really like the music. The music kind of is perfect for just galaxy and awesome views, Which you can't hear the music, of course, because I didn't share that part. There we go. That's more like it. Wow. Jennifer Miko is with us. Hello, Jen. How are you? It's so nice to see you. I haven't seen you for a long time.
Me neither.
Yep. Yeah.
See another galaxy in the background down at about 4 o'clock from...
This one?
Yep.
Yep. Again, these lines are artifacts that I'm going to get rid of when I get out there. So I'll be taking care of that. Neutrino says we're all connected. It's nice to be part of something so beautiful and amazing. And you know what? That's I think Jenny would agree with you there too. Because I know Jenny personally, and I think that that's kind of how she lives her life as well. That's wonderful.
Oops. Mark, would you excuse me a moment, please?
Yeah, go ahead.
Be right back.
All right. So this galaxy, called the Needle Galaxy, I'll move it over here for now so I can bring up the planetarium and show you a little more detail. This galaxy is interesting because it's about 56 million light years away. 56 million light years away. That means the light you're seeing this time, tonight, right now, this instantaneous light, it came to us just a few million years after the dinosaurs died. It started leaving that galaxy 10 million years after the dinosaurs died and finally reached us. So think about that. The universe is so big. It always leaves me awestruck. That's why I'm an astronomer. I can't put it aside. It's just the most incredible universe out there, and I just love sharing it. And those of you that are here, I'm very happy you love to see it. Very, very cool. There's 53 of you watching right now, and I'm glad to see that. It's so exciting to see you out here. Oh, Tara Diulis and Tara D in the chat. She had an encounter with a rattlesnake. And she sent me pictures of it. And where was it, Tara? Was it on the porch? Tara will tell us. Wow. Let's just pull this bait for a little while, just to hang out. Look at that. Yeah, on the porch, yeah. Now, I've gone to Arizona a lot, you know, but I have yet to see a rattlesnake. I can tell you this, and you might be grossed out by this. It's the best meat I've ever had. Rattlesnake tastes so good. Sorry, it's true. It is so good. Ugh. And Tara was standing right next to it by your feet. I am sure she probably stomped it out of existence. Well, I'm sure she didn't stomp on it. You have a snake hook? You have a wrangling hook? Just grab it and twist it around, and I'm not sure what you did. Look at grape soda. Gross. No, actually, it isn't. The second best meat I've ever had. I don't eat meat a lot. Okay, I can't stand steak. It makes me sick. But is alligator tail. Alligator is really good too. So, if now I'm not a hunter. I don't eat stuff like that. I don't hunt things. But if they are in my way, or they are going to encroach on our, property, right? You gotta defend your property, and if they become a nuisance and sending them away doesn't help, and they keep coming back, well then you need to take other methods. Oh, Tara says that it's so dry the snakes are coming in for water. Yeah, I believe it. Southern Alberta has rattlers, yeah. Well, we didn't have mountain lions until just recently, but now they're back, and they're like a mile from here. There's a mountain lion that's been seen, and so I'm thinking that it's a good thing that everything is remote, because I'd rather not have to be out in the observatory on a night where I might encounter a nocturnal hunter like a rattlesnake, or a Gila monster, or a tarantula. I saw a tarantula the size of my hand right outside the door of this observatory. And I like them. I think tarantulas are really cute. Yeah, and the ones in the United States, they can give you a bite, but they're not gonna hurt you. They don't have venom that can kill you. Welcome back, Daryl.
Thank you. Do you see rattlesnakes at night out there?
I've never seen a single rattlesnake, but they are nocturnal hunters too, so that you would see them at night. Yeah. And they're out during the day.
Yeah, we have rattlesnakes here. I have never seen one, but I think they're more daytime animals just because it tends to cool off more at night here.
Yep. Michael Klagus, my cousins are alligator hunters down in Florida, and they have threatened to take me on an airboat and go hunting alligators with them, because they have certain number of tags for alligators that they can take each year. And I have yet to do this. I've yet to do that. I don't kill anything, by the way. I'm not one of these guys. I don't do that. I mean, I save spiders in my house. I think they get rid of pests, and tarantulas eat pests too, just like you said as well, Neutrino. And I think that's true, so why get rid of the things that help you,
Yep. I leave spiders alone, they leave me alone.
Yep.
The only problem I'm having right now is the annual Miller moth migration is
oh yeah.
And they're a little late this year, and they're straggling, but those things will drive you crazy, and they get in your house at night.
Yeah.
Sometimes after I go to bed and the lights are off, I feel them flying around and bumping into me.
And then you hear them, like, you hear the noise. The bigger ones actually make a sound.
Yeah.
Yeah. It's crazy.
Sometimes they spit on you too, except it's not spit.
Okay. I don't think I need any more information.
Yeah. We have tarantulas here too. They go on a yearly migration or excursion, something in a little town down southeast of here.
Oh,
It's
very cool.
Kind of an annual event. They all get up and go looking for girl tarantulas or something. I'm not sure what it is, but
Wow. Well, the drive is pretty strong.
you talk about drive. I mean, they cross the highways and you tend to run over them and stuff.
Yeah. Wow, this is really pretty. Okay, we're gonna let me bring my telescope back here. Okay. There we go. And okay, now 35 of these have been stacked, and we're gonna pause this and save the Needle Galaxy. I'll call it the Needle Galaxy. Okay.
Ricardo mentions brown recluse.
Oh yeah, brown recluse is not fun.
They're supposedly not native here. I have heard of them like being carried in from out of state, and I've known one or two people that have been stung by them here, supposedly, but supposedly they're not a native species.
Yeah.
Here in Colorado.
You know what? If they can survive the winter, they're a native species. Okay, let's see what else we want to see now.
We get wolf spiders here. They're
they're
good
harmless.
spiders. Yeah.
Yeah.
They eat the bad bugs.
Yeah. I let the spiders live in my house.
So do I, generally.
Lambda Theta Psi. Spiders don't like peppermint and avoid it. As well as mice. Mice don't like them as well. There's Ricardo. Alright. Yes, brown recluse can cause necrotic necrosis. Yes, exactly. Yeah, and it just keeps spreading, and it's like, oh my gosh, I don't really want to have a run-in with a brown recluse. Thank you very much.
Yeah. A guy at work got bit by a brown recluse on his ankle, and the necrosis was really bad.
So he had a hole in his leg for a year or two, right?
Something like that.
Yeah. Wow.
It's down on the side of his foot.
Yeah. Alright, let's do the Whale and the Crowbar, because this is actually pretty interesting. I'd like to see what we can see right now with the whale. So, here we go. Off we go. Okay, we're doing high precision slewing, and I just have to give myself the 1 second shot again, and do our... Okay. Look at that, it's a double star we're going to. Cor Caroli. Wow. I guess it's pretty bright in the sky. This dark center is because we're actually doing something called a flat field correction. And when it's really bright, it makes it look kind of odd like this. So sorry about that. It won't look like that if I did this. If I just bring that back down.
I see you're shooting at 4 milliseconds instead of 1 millisecond.
Oh. I didn't want to do that at all. That's why I didn't see anything, because I was trying to do a 1 second shot.
Oh.
Alright. Alright, that's better. Okay. Now, our whale galaxy is in the middle of the view. Let me actually show you again. So I come back up here. There it is. And you'll notice down here there'll be another one, okay? Alright, so what we're going to do now is we're going to go take a 25-second shot of this one. And we'll live stack it. And it's going to be really pretty. Our progress bar is on its way up down there. This is great, isn't it? I mean, isn't this fun? Yeah. Hey there, C&D boy. How you doing? He says, we've been gardening and painting birdhouses all day, but I'm here. Yes, you are. I'm impressed. Awesome. Drop this down. There we go. Look at that. All right.
Also known as the herring galaxy. At least they didn't call it the sardine galaxy.
Yeah. Wow, look at that. Okay, let's zoom in on this. Let's zoom in and watch. This is the whale galaxy right here. And this is called the crowbar galaxy for obvious reasons. It looks like a crowbar. You'll notice the crowbar galaxy has this view, this look where it has this arm that kind of goes bending down. That's because it's had gravitational interactions with other galaxies in this region of space. And galaxies are very fragile. They will tend to tip and warp and do all kinds of things. And that's exactly what we see here. You know? Cosmic Ray says, where can I find info about equipment you're using? Well, that's easy. I can tell you. You know, I actually, if you want to see it, you want our server, and I have a photographic compendium of the building of the observatory showing the finished telescope in there. We are using a 10-inch Meade LX600 system that is normally runs at a photographic speed of what's called f8. That's kind of middle of the road, not fast, not slow optically, but we actually converted it to run at f2, and we have we kind of short-circuited the way the telescope is used, because normally on the Schmidt-Cassegrain telescopes, light goes down in the tube, hits a main mirror, comes up to a secondary mirror, then goes back down through a hole in the middle of the primary mirror out to a waiting camera. Well, we short-circuited that. We go down to the main mirror, we come up to not another mirror, but a lens system that sticks out of the front of the telescope and goes to a camera that's sticking off the front of the telescope. This is a system that allows us to not only see a wide field, but makes the telescope run 25 times faster than normal. So that's why a 25-second shot can show you faint galaxies like this. And actually, the truth is, this system is the only one in the world that actually has one of these special lenses called a hyperstar installed on it. They're not made for this telescope, and we had one made especially for this telescope. And now the company that makes them is called Starizona down in Arizona in Tucson. And Starizona can offer them for these telescopes now. So we were the prototype, and now we've paved the way. And as you can see, it gives beautiful results. Just beautiful results. I think it's pretty cool. You know?
Just needs some nice color in the whale.
Yeah. That's right. And the whale on a fully dark night, you can actually see a lot of detail in here. This red area here, these are areas where star formation is taking place, and these are places called stellar nurseries. the Orion Nebula in our galaxy that we have, in the Orion arm of our galaxy, where we are kind of located nearby, the Orion Nebula and those nebulas you see in the summertime sky, the Lagoon Nebula, those are reddish nebulas. And those are stellar nurseries. And they're ionizing hydrogen with their powerful, bright, hot stars. And ionized hydrogen will glow red and cause these clouds of beautiful red gas that you see. But you also have that dust mixed into that gas as well. So you can see these beautiful red nebulae with lanes of dark in them. Oh, looks just beautiful. The Rosette comes to mind, the Rosette Nebula that we often look at in the winter. Alright, so let's see now. Let's bring up our dark level here just a little. Okay, that's a little much. I'll back it off a bit. There we go. Let's see if we can reduce the noise a little bit. Under enhancement, I'm going to remove the bilateral filter. Okay, so now we can see more detail in the galaxy here. So if we zoom in on this galaxy now, you'll see more detail inside the galaxy. Look at this. You can almost see the spiral structure. We're kind of looking at it sort of like this. It's kind of like that. It's not like this or edge on. It's kind of like a galaxy like this. And there's another galaxy here. This is a galaxy that I believe we talked about before. Daryl, is this interacting with it?
Yes.
Because I thought it was. Yeah. Oh. I heard rumbling and I wondered where that was coming from. It's coming from here. We have a thunderstorm whipping through. Justin T, what's up? Ricardo says, not to start a panic, Asian beetles versus 1960s beetles. Oh, I want to hold your beetle. Yes, I don't think so. That's pretty cool. Vera Lucia Campos says, the squid and the hockey stick and puck. That's actually very clever, because I believe that this galaxy also has a nickname of the hockey stick, doesn't it?
I think you're right.
Yeah. Pretty cool. Neato. Oh yeah. Beautiful galaxies. Now let's talk about the Whale Galaxy over here. The Whale Galaxy is a galaxy that is about 22 million light years away. It's really beautiful. This red square, by the way, this is our field of view. So with the whale here, you should see the Crowbar Galaxy down here, and that's how it works. It's okay. If we zoom out, you'll actually see the placement better. So let's do that. So we come up here and go like this, and now you see that we have the whale and the crowbar, right? So if we come over here, the telescope is sort of leaning over, and so you're noticing that it's this way. If it's far over toward the west, then it's going to start leaning over, and that's why it's sort of on an angle like this. But we're actually like this. Let me just put this where it belongs. Okay, so that's kind of what we're looking at right there. Really cool. Yep. Yeah, that's right. The Great White Whale Galaxy, right? That's like the Moby Dick. Remember that Herman Melville's famous story? I read that to a second grade class as a second grader. They had me reading stories because I could read so well when I was a kid. So I sat there in front of, I think it was to keep me out of trouble. And it was like, "Call me Ishmael." That was the first line in that book.
Yep.
Yeah. All right.
Do you remember chapter 9? Do you remember chapter 94?
In that book, was that with Queequeg?
I
Queequeg is a
hesitate
character.
Yes, I know, but no, it wasn't Queequeg. It was
Okay.
it's called a squeeze of the hand. And if
Okay.
you got all the way to chapter 94 as a second grader, and you read that, I'm surprised the teachers didn't stop you.
Oh, I see what you're saying. The book I had, the Moby Dick version I had, was a condensed version.
Okay.
But again, it had lots of pictures, and I had to show the pictures too to everybody. As I
Okay.
They were trying to keep me out of trouble. You understand? I was just, what do you call it? Precocious.
Yeah.
Yeah, I was what you call precocious. Yeah.
Folks,
that's
if you have any curiosity about what we're dancing around the edge of here, just do a Google search for Moby Dick, chapter 94. It's called The Squeeze of the Hand.
I think you should just leave it at that.
Yeah, it'll weird you out.
Okay. You know, I actually have whale oil lamps here that I was given by my uncle. He was a Navy diver, and he dove on a ship and recovered them. It was an old vessel, and they had whale oil lamps. They were big brass lamps. Actually, the running lights, red and green. And they're in the back room, and they're just big, giant brass lamps. And I've had so many offers for those things. And I have a captain's lamp, too, which is, it goes in like a captain's cabin. It's just a beautiful lamp. I was, because nobody can see it, but my office here is made up to look like an old World War II battleship. And at first, the running lights were going to be mounted in here, but then those are from sailing vessels, so it didn't match, so I didn't use it. Okay. We're at 26 stacked here. This looks pretty good.
Whale oil was considered to be fine machine oil back in the day, too.
I think you're right, yeah.
Excellent lubricant.
Yeah. Whale and Crowbar. Galaxies. That's what that's titled. All right. There we go. And we are going to save the stack. There it is. It's saved. And save it exactly as seen. There it is. It's saved. Now we'll clear it. And if any of you have any questions, by the way, please go ahead and ask. Don't hesitate. If you're interested in what I do, I'm the chief photo and video analyst for the Mutual UFO Network because of my interest in extraterrestrial life. But I'm also an astronomer. That's what I went to school for. And I spend time learning about extraterrestrial life and how planets form and, how life could arise in the universe. That's sort of my specialty. And to that end, I wrote a book called The Populated Universe. Okay, The Populated Universe. And it has to do with the fact that we're carbon-based beings and that I think that life in the universe is the rule and not the exception because of the prevalence of carbon. Carbon is the fourth most abundant element in the entire universe. The third most abundant is oxygen. Second is helium, and first is hydrogen. So those top four, they've kind of cornered the market on building blocks, except for helium. Okay, but hydrogen, carbon, and oxygen are really the three very, very important elements that you find in DNA. So that's very important to see that. And so the book is about, and it's written for everybody. It's not written for science people. It's written for people who want to learn about why life is so prevalent elsewhere, in my view. And there's a lot of people that believe what I believe with this too, so this is good. Where do you want to go next, Daryl?
Oh, I don't know. you want to do more galaxies, moving away from the moon might be good. Maybe up in Ursa Major. Or
Yeah, that's true.
let's say you're, where are you now? In Coma?
Yeah. I'm actually pretty close to Ursa Major, just over the top here.
Yeah, and there's Canada's Venetici right there.
Yeah.
All the usual suspects.
Yeah, I'm thinking them.
M51,
Yeah.
M100, M101.
Yeah, we could try those, right? Because those are right nearby.
Sure.
They're just over the top. So here's what we're gonna do. I'm actually gonna try. I'm not gonna do M101, and that's because it's probably not gonna be too bright. But it's okay. I'm gonna go for what's called M51, and here's where we are. We're gonna go there. So we're gonna go there now, and M51 telescope's gonna tilt way back and head in another direction. You'll see it right over my head. You see it moving. Okay, here it goes, and it's gonna find a star. There will be the waypoint star, and it's probably gonna use Alcade here in the Big Dipper, the N star in the Big Dipper. Oh, you know what? I love showing them Mizar and Alcor. So I think I want to do that as well. But I'll do M51 first.
Ursa Major's going away, you know.
I see it.
Yeah, it's getting down in the northwest now.
Yeah. All right. And there is our Messier 51. Messier 51 is a galaxy in decline, actually, because it's a galaxy that has collided with another galaxy, and it's in the process of being ripped apart. Okay, there's a Whirlpool. It's called the Whirlpool Galaxy, and to understand why it's called the Whirlpool Galaxy, we have to take a photo. So we're gonna do that. It's a face-on galaxy to us too, so it's face-on. This is edge-on. This is face-on. This is a face-on. All right, so let's do that.
Say goodnight, Tara.
Tara's going nighty night. Oh, Tara, thanks for coming, Tara. It was really nice to see you. Good to see you. You have a good night, okay? I'll see you soon. I'll be out there in just a few weeks. Okay, 25 seconds here. Get rid of that. Hypered shot. Let's go into the live stack. Get some data, baby. Here we go. Alright, we're guiding. You can see the guider right there doing its thing. Yeah. You're gonna love this galaxy. Check this out. Look at that. Wow. Now, when the second one comes in, watch how the noise goes away. All right, let me just zoom in a little bit. Okay. Looks noisy and lousy, right? Now watch what happens to all this noise as soon as the second exposure comes in. Right about now. Here we go. Boom. Look at that. The data is getting averaged out, and now we're seeing more of the galaxy. Isn't that cool? That's what stacking's doing for us. And that's only two images stacked right now. Let's do this. Get the galaxy colors right. When the third one comes in, it'll be more of that same. See? Noise is getting reduced. Galactic arms are showing up more. Really something. I'm going to take this out just a little bit, kind of reduce the dark a bit, just to show a little more data. And then I'm going to move us down here to kind of help get rid of some of the noise without sacrificing the quality of these spiral arms. Look at that galaxy. Wow. Come here, you. Yeah. Now, if you want to know what's going on, you can probably just barely read down here. We have 4 stacked, it says. Right there. Now we have 5. The sensor is minus 8.4 Celsius. That we run an ultra cold camera sensor out there, just to make sure that we reduce the amount of noise that's on our sensor in our results like this. And as you can see, we actually lose noise pretty quickly here. This is literally one of the best cameras you can buy for doing what we're doing, if not the best. Really, really cool.
Have any idea of the temperature there now?
Yeah, temperature is 32 Celsius out there. So you can convert that to Fahrenheit if you want, but we're probably talking in the 90s.
Yeah, I just wondered if your target temperature never did hit minus 10 C. You're at 32 C right now?
I am. Celsius.
Yeah.
In the building. That's the temperature in the building. It may not be the temperature out. It's very close to being outside temperature too. We want the temperature to be the same.
90 degrees, close enough.
Okay.
89.6.
Alright. Alright, here's what we're going to do. Alright. We're at 120%. I'm going to drop us down to auto mode here for a minute. And then I'm going to clear the stack. Why would I do that, you'd say? Well, because what I want to do is do a critical focus again. Because the focus is off a little bit. I noticed that it's not quite perfect. So we're going to go to our 1 second shots again. And go to our hyper view. Alright. And the hyper view is going to help us with focusing. So here's what we're going to do now. And you'll get to see, this will work really nicely because now it's more than dark enough to do this. So we're going to go into our tools. And actually, let me pull the focus out a little bit, because that's kind of important to do. I'll pull the focus out, make it... Oh, and I have my dog has showed up. Hello, Dingo. She came to see me. Okay, and now that I did that, I'm going to go into Tools. I'm going to Focus Assistant here. Multi-star, full width, half maximum process. And now I'm going to scan inward and find the focus position. So now what it's going to do is it's going to look through all these stars, and it's going to try to find, as it moves the focus automatically, it's going to find the point where the star is the most focused, and it's going to look at all. We got a lot of stars, so we're going to get a good result. And then it's going to make a curve, and that curve will have at the bottom of the curve, that's where the best focus is going to be, at the bottom of that curve. So if we look at what it's doing, right, we can see that it's starting to go down here like this, and then it's probably going to go back up. And the middle is where our best focus is. So it does 12 steps where it samples different stars throughout the process. There we go. It's found its center. There's our curve. So it goes all the way from the out of focus to into focus to out of focus. And now, as you can see, it says it's already been found. So now what we're going to do is we're going to say go to the best focus position. So you'll see it's going to slide across. The focuser is going all the way out to this way and then all the way back to the middle. Bam! Now we have our critical focus. I used to do this manually. Izabela. I thought men are, women are from men are from Mars, women are from Venus. Isn't that what it is? Instead, Daryl's from the Sombrero galaxy and I'm from the Pinwheel. Well, thanks a lot. See that, Daryl? You're from the Sombrero galaxy.
Why the sombrero?
I don't know. Ask Isabella. She said it.
Wife
Okay,
from
25
the Sombrero.
seconds. 25 seconds here. And we're gonna... Oh,
What's that supposed to mean?
I don't think you want to go down that route. Okay.
She's making fun of my beautiful, naturally curly
Bring
hair,
my-
I think.
Yeah, I got that too. So she could have been talking about either of us. Ah, there we go. Okay, so now we're really focused well. So as we zoom in again, you watch the noise. Now, again, I'm going to zoom way in because I want to show you this. All this mottled noise, it looks like a real crappy picture. But watch now as we stack an additional single image now onto this. Ready? Watch this. Boom. A lot of it goes away, and it will keep doing that all the way through as it keeps stacking images upon images upon images, and the data is going to get brighter and more pronounced, and the noise gets subdued. That's what stacking does for us. It's the best approach, and it's in perfect focus now. Hello, Dingo. There we go. All right. So we've stacked 3 so far. Renee Cruz says, why does interstellar outer space smell like burnt brakes and raspberries, gunpowder, and seared burned steak? Why? That probably has to do with the molecules that are being inhaled by the astronauts when they go back into, say, a capsule from being out in space. When the astronauts come in from the ISS, spacewalks, their spacesuits have a certain odor to them. It's kind of interesting, all right, because these spacesuits are obviously not supposed to be smelling like anything, but they do. So how does that happen? It has to do with the way the sunlight hits, the way the protons from the sun and the solar wind are striking the spacesuit. Plus it has to do with the other small amount of molecules and atoms that are in the space around the ISS. And, under the hot, searing ultraviolet radiation of the sun, you can get different odors than that get outgassed from these suits. And one of them is burnt steak. One of them is gunpowder. The moon smelled like gunpowder. And it wasn't gunpowder, but it just smelled like it, Hey, Dean Bostador, how you doing? So good to see you. Don't worry about being late. You're not gonna have to stay after school. I promise. But I think that whole thing about the smell of space is a very, very fascinating thing. Fascinating story. Hey there, MLR. How are you?
If space is empty, why does it smell like anything?
Well, because it's not quite empty. There's a lot of junk out there. A lot of molecules and atoms floating around there. MLR says full strawberry moon this month. There we go. Let's zoom in now. That looks pretty cool. See these beautiful spiral arms here, and this is with a nearly full moon. We're able to see this detail, so we're actually using some really high-end filters on the camera to help us get rid of the moonlight, but it also allows us to see moonlight so that we can actually look at the moon and not have to be limited. Hey there, OG Skywatch. Thanks for putting that show description up there. Excuse me. This blue line here is just from the camera. We get every now and then for different photos, the sensors. The sensor has certain pixels that may not work. They're not the same ones every time. So we have a green one here. It's RGB, red, green, and blue. So sooner or later, you keep looking around, you'll see a red line as well. The most common one is the blue. I don't know why. I'm sorry, I'm cough now all of a sudden. That's what I need. Okay. Neutrino, thanks for coming, man. You have a good night. Alright. Good to see you. That's really pretty. Let's see if we can affect this color. Bring this color down a little bit. That's a little better.
Alice is interacting with another galaxy, yes.
Yeah, actually, I didn't even go through that. I'm so sorry. I should have said so. This spiral galaxy here is interacting with this galaxy here, as Daryl just said, yes. Now, what's interesting is the universe is in 3D, and when we look at this galaxy, you'll notice a couple of things. You'll notice that there's some weird shapes to these arms, like right here. Okay, this arm has this weird little point on it. What's going on there? Well, that's where this galaxy is tugging on the outer edge of this galaxy. But you have to understand that this galaxy is a little further into the page, okay? It's below, if we're looking at this galaxy's level, this galaxy's down below. And that spiral arm that you see here, okay, it originates above the plane. So this galaxy passing through, as it goes through, it's actually pulled that spiral arm down. So from the front, it looks like this, or like that, but from the side, it looks like this. Okay, so that's what we're seeing there. We're actually seeing this, that this arm here is curved downward toward this galaxy as they've passed through each other. Now, on the fully dark nights, we can actually see the rest of the detail here. We might be able to see some of it here. If I pull back the dark level somewhat, we might be able to see the rest of what's going on here. Yeah, it's kind of hard. There's actually a lot more fuzzy material, that you can see here. Streams of stars and dust and gas that have been brought outside this galaxy. Oh yeah, Sphere X MLR, that's right. We should talk about that in our radio show, Daryl.
Sphere X?
Yeah.
I'm not too up on it.
Yeah, it's the mapping mission. Alright, that's no problem, we'll do it. Yeah, the Twilight Zone Outer Limits to Serve Man. It's a cookbook!
Yeah.
Yeah.
Really Daisy and Zoe said that a space creature having a summer backyard barbecue would smell nice, which reminded me of
to Serve Man.
Yeah. I think it was Outer Limits.
Okay. I think you're right. I don't know. I think you're right. I don't think Rod Serling was in this. Ricardo, I think you missed Tara. She left a while ago. Unless there's another Tara in here that I didn't see. Hey, Jessica S., how you doing? Just in time for the Whirlpool. See that? Wow. Big majestic galaxy. We've stacked 23. We're gonna pause here. I have the Whirlpool galaxy. It's actually I don't know why it got named the Whirlpools galaxy. It's not the Whirlpools, it's just the Whirlpool galaxy. M51 Whirlpool. Boom, there we go. Alright. And now let's do this. Let's pause it here with 24 stack. Let's do 25. There we go. Got 25. We'll pause it. Save it as a raw file. And then we will save it exactly as seen. And there's our ping file. So now we have saved it and we can clear it. And now I can go to that double star I was telling you about that I'd like you to see. Remember last time I did this, what happened? Not last time, but one time I did this and the telescope actually had a failure, which ended up causing multiple failures down the line. It was something that has been fixed, so we don't have to worry about it anymore. Alright. Otherwise, we'd be having trouble going here. Alright, let's just pull this up. And I think Mizar is going to be our last view for tonight, Daryl.
Yeah, I was about to say I'm going to have to call it pretty soon.
Yeah, okay. In the handle of the Big Dipper, okay, is Mizar and Alcor. These beautiful stars that are double stars. But they're double stars in each and of themselves. So it's pretty interesting how these stars look. So we're going to go there. This is Mizar and Alcor right here. And we will zoom in and try to show you these stars with a little more alacrity and descriptology. Alright, so what we're going to do is this. We're going to zoom in on these. Alright, and we also, by the way, it's a little windy out there too. We have 35-mile-an-hour winds, which is why you see some bouncing around right now. Okay, but you notice this is Mizar, and there's a double star. It's got another little component right there. If I actually drop down our exposure, let's go down to just a half second. That's 500 milliseconds. All right. All right. Okay, you can see it a little better. Let's drop it even more. Let's go down to 250 milliseconds. Okay. There you go. And now if we zoom in, you can see that Mizar has a double. It's a double star, and they are orbiting each other. You just can't tell because it takes so long for them to go around. Hi, Fantasy. Yeah, see, Fantasy's feeling some pretty heavy-duty winds out in the desert. And look at that. And this is Alcor over here. So this is the double. This is a double star. This is, I believe that Mizar actually has a physical double, but I believe it has a spectroscopic one as well. Is that not true? I'm trying to remember. too. You're looking these star is not involved, I don't believe, but Mizar and its visual brother right there. You're looking at 4 stars here. Mizar has a star orbiting it very close that we can't see, except in the spectra. The component down here also does, and then this star here, which is orbiting Mizar as well, it has its own double. It's its own double as well, a spectroscopic binary. So very, very interesting to see all this. So now let's do this again, and let's clear the stack and see if we can show this a little better. Okay, there, that's a little better. Now let's do this, and let's take down some of the brightness. Okay. That'll be cool. That'll allow us to show it. So we'll be able to see Mizar and Alcor. Okay. And I like that. Okay, and these are double stars. All right, cool. And now let's go into our stack here. Okay, we've stacked not a whole lot. Hold on. I see what happened. Yeah, what's happening is our time is so short that we didn't have enough stars to stack because we're doing just 100 milliseconds at a time. But maybe if we increase the sensitivity, we'll get more stars that can stack. Let's find out. No, we gotta do let's just do 1 second shot. And come in here. It'll be pretty bright. And we'll get rid of this. Well, that's 1,000 milliseconds. There we go. Kind of losing that a little bit. Maybe we can work on that. Okay, and that stack's working. Yeah, we're not going to be seeing any planets tonight, sorry. You know, I'm not even going to go look at the moon tonight because that's going to just blow everybody's vision out. You know? Good night, Grape Soda. Thanks for coming. And Dean, thanks for coming as well. Everybody, thank you for coming. We'll be finishing this up here in just a second. We got 37 stacked, and we'll do that now. We'll just say save, and then save exactly as seen. All right, and that is on its way up to the server, and away we go. Well, folks, you've done it again. You've wasted another couple of hours with the nutcases that are the folks here that run Skytour Livestream. But I want to thank you for coming and checking this out with us. We really enjoyed your company. And I think that we had a few good sights, even though the moon was almost full. You agree, Daryl?
Uh-huh. Oh, yeah, absolutely.
Yeah, not bad. Not bad at all. So anyway, we will be back. We're probably gonna just hang out till after the moon cycle. But you know what? If it's clear out there, I just can't help myself. I always have to run the telescope. There's so much to show, so much to see, so much to do. But anyway, I'm just happy that you guys all came out. I want to thank you for coming out, and this is it for tonight. We will be back on another clear night after this. So good night to all of you, and we'll see you again.
Good night, Gracie.
Very good line. All right, good night, folks.